finding the length of a line segment in coordinate geometry. There is a formula method for this. If you would prefer to learn to use this formula for the distance between 2 points, please watch the other video instead. I'll also go through how it works in that video. You don't need to write down all this how it works, because when you're asked a question like find the length of the line segment, that means part of a line, oh, you can hear my cat meowing in the background, between these points, you won't draw the number plane to do that, but drawing the number plane lets us see how it works. Ordinarily, we'll just work it out mathematically. So, here I've plotted these 2 points on the number plane, and they want us to find the length of the line segment between them. That is, this line that goes straight from one point to the other. Now, previously we've worked out how to find the distance between 2 points that are vertical or horizontal from each other. So if I go down to here, horizontally in line with that point and vertically in line with that point, you'll see that what I get is a right-angled triangle. And on the diagram, it's really easy to work out the distance in units on that side and that side of this right-angled triangle. This is 2. This is 1, 2, 3, 4. We're not counting little grid squares. We're counting units on the number line. And once we've got those distances, we've got a right-angled triangle, and we can use Pythagoras' theorem to work out the hypotenuse. So it's really quite simple from that point of view. The challenge will be to work out those distances when we don't have the diagram. And let's look at how we do that. We'll also look at how we use Pythagoras to get that length. So let's switch up some colors. This distance here on the horizontal is the x values. So this one here is -3, and this one here is -1. And you'll see it's in that coordinate there. To get that distance, basically what you're going to need to do is subtract the values. And you're going to do largest value minus smallest value, but do remember that -1 is actually larger than -3. Maybe you'll feel happier if I do the y values first, because we're in the positives and you'll see how it works. Then we'll do the x values. So the y values, this one's 5, this one's 1, and you can see where I get those from the points. So this value here is 4, and you can see really clearly 5 minus 1 is 4. So your vertical length sorry about my notifications there. The cat's meowing. I've got notifications. I'll see if I can turn those off. Vertical length is 5 minus 1, which is 4. Largest value minus the smallest value of the y's. Remember, we're x and y. The horizontal length is again going to be in the x values, the largest minus the smallest. -1 minus -3. Tricky. Remember from year 8, negative minus negative is positive. So negative 1 plus 3 is 2, and that is the horizontal length. So a little bit tricky. If you did it the other way round, it did negative 3 minus negative 1, you'd get negative 2. And you can't have a negative distance. So it would all work out if you tried to do it, but it might be a bit confusing. If you get really stuck, you can always plot your points, or you can go and learn how to use the formula, which will always work. Up to you. Now, once we've got the vertical length and the horizontal length, those are the two short sides of the right-angled triangle, and we use Pythagoras. C squared equals A squared plus B squared. We want C, the hypotenuse. So C squared equals, now A and B are our short sides, 4 squared plus 2 squared. Now here's where that little trick comes in. If you'd done it the other way round, if you'd got negative 2, you could have written negative 2 squared, and when you square a negative in brackets, you get a positive anyway. So it would work out. If you end up squaring a negative, just remember to put it in brackets. Negative 2 squared is 4, just the same as 2 squared is 4. So if you get your points the wrong way around, it won't matter if you remember that squaring a negative is a positive. So we get our answer for C squared. That would be 4 squared is 16 plus 2 squared is 20. In Pythagoras, when we've got our answer for C squared, we then need our answer for C, which is the square root of 20. Grab our calculator. Square root of 20. Now remember that when we hit equals or enter and we get a funny answer, we push the arrow key to get a decimal answer. They said 2 decimal places. C equals 4.47 units, because we're in units because we're on the coordinate geometry plane. So I know how to do it sounds a little complicated, but let's try this sort of example. Find the length of the line segment joining negative 1, 2, and 4, negative 1. So we start with our vertical length, and that's the y values. Largest minus smallest, 2 minus negative 1. Minus a negative is positive, so 2 plus 1 is 3. Horizontal length. That would be the x values. Largest minus smallest, 4 minus negative 1. It's 4 plus 1, that's 5. So those are the two short sides of a triangle. Then we use Pythagoras' theorem to find the hypotenuse. C squared equals A squared plus B squared. These two are A and B. 3 squared plus 5 squared. Get our answer for C squared. 3 squared is 9. 5 squared is 25. Get our answer for C squared. 9 plus 25 is 34. When you've got your answer for C squared, C equals the square root of that. Square root of 34 just gets square root of 34, double arrow key, 5.83